Given, two non-negative integers number 1 and number 2, both written as strings. Return, their product, also written as a string. Because the inputs are strings, the example behaves like written multiplication, digit products, carries, and a final string. In this example, each row of the written multiplication contributes one shifted partial product. After the carries settle, the final output line is 56088. You are tasked with multiplying two numbers given as strings without using any direct conversion shortcuts or big number libraries. If your immediate instinct is to copy the manual method we learned in grade school, creating independent intermediate rows for each digit, padding them with 0 characters, and progressively running a multi-line addition, you will struggle with heavy text manipulation overhead. We need a way to process these digits silently in place. Before we multiply a single digit, we can mathematically predict the exact maximum length our final answer could possibly take. When you multiply any two numbers of lengths m and n, their product will never exceed a total length of m plus n. By pre-allocating a simple list of zeros of this exact size, we build a static landing strip where our digit products can drop in without any dynamically changing sizes. Here is our massive paradigm shift. We don't need to append trailing zeros to mimic place value columns. The placement is entirely deterministic. Whenever you multiply a digit at position I from the first string with a digit at position j from the second string, their mathematical place values guarantee that their product belongs exactly at index I plus j plus 1 in our destination list. We can map every cross-multiplication combination directly to its final destination bucket. With our coordinate map established, we run a nested loop in reverse, multiplying our numbers from right to left. We peel off single characters, convert them to their raw numerical equivalent, and add their product to whatever is already sitting in our target slot. The list acts as a series of collection buckets, absorbing raw sums from every overlapping column combination. Once all multiplications are compiled, our list holds a series of unrefined, multi-digit sums. To clean this up, we run a single backward sweep from right to left to propagate our carries. We keep the remainder of a division by 10 in the current slot, and pass the quotient forward to the left neighbor. A single smooth wave stabilizes our values into perfect single-digit mathematical alignment. Finally, we transform our numerical data back into our required text format. We skip past any unreached leading zeros at the front of our list, stitch the remaining digits together into a single cohesive string, and return our result. We've bypassed the text manipulation bottlenecks entirely, delivering an elite, linear space solution. Let's walk through the solution engine step by step. First, we record the lengths of both input strings. Using these dimensions, we pre-allocate an empty list of integers initialized to 0. Its length is exactly equal to the sum of the two string lengths, ensuring that no matter how large the product grows, our results pool is guaranteed to hold the entire footprint without needing a single resize. Now we launch our primary cross-multiplication engine. We spin up two nested loops that traverse our strings completely in reverse, moving from right to left, exactly like we do on paper. In each step, we extract the characters at pointers I and j, strip away their text formatting to isolate their raw numerical values, and calculate their product. Instead of shifting rows to manage place values, we use an index prophecy. Multiplying a digit at index I with a digit at index j means their combined product belongs exactly at index I plus index j plus 1. We target that index directly in our list and add the product to whatever value is already sitting inside that bucket. No trailing zeros, no row tracking, just pure coordinate mapping. As our loops progress, different digit combinations will naturally map to the exact same place value buckets. The slots act as collection reservoirs, absorbing and accumulating raw sums. When our nested loops finish their run, our list is packed with raw, uncarried totals. To refine these raw totals into a real number, we run a single backward sweep across our list to process the carries. Starting from the very last element, we take the value modulo 10 to keep only the single digit behind, and pass the quotient forward to its neighbor on the left. A single linear sweep perfectly balances the place values across our entire number structure. Finally, we prepare our data for delivery. We skip any unreached leading zeros at the beginning of our list so our answer doesn't print awkwardly. We stitch the remaining valid digits back together into a single, cohesive text block, and return it. 2 edge case guards finish the job. If either input is the string 0, we return 0 immediately, no multiplication loops at all. After trimming leading zeros, if nothing remains, we still return 0, not an empty string. Complexity. Let m be the length of number 1 and n the length of number 2. Time is O of m times n, the nested loops visit every digit pair once, with constant work per pair. The backward carry sweep after that is linear in m plus n, space is O of m plus n for the result array of digit buckets. Pseudocode for multiply strings. Early out if either input is the string 0. Allocate a result array of length m plus n, all zeros. Nested loops walk both strings from right to left, each pair multiplies its digits, adds into bucket index I plus j plus 1, and propagates any carry 1 slot to the left. Finally skip leading zeros in the array and return the remaining digits as the answer string.